end of the day, you will be able to appreciate what is happening. Thank you, everyone, for the congratulations. And I hope tomorrow I would also be congratulating you for your own discovery and for your own inventions. So we'll look at machine learning in public health. So first of all, what is machine learning itself? So confirm you can see my slide. Yeah, thank you, Christopher and everyone. Confirm you can see my slide. Yes, okay, very good. All right, so let's progress. So machine learning in public health. So what is machine learning? Machine learning is equal to teaching computers to learn patterns from data so they can predict or classify things. Let me give a very simple analogy of machine learning being in operation, but a lot of us are not even aware that it is machine learning. For example, you're watching Netflix and you finish watching a movie in Netflix. And as that movie is finishing, Netflix is recommending another movie for you. And you would realize that oftentimes when you finish a movie and Netflix recommend another movie for you, you will see that that movie will be quite interesting, almost like what you just finished watching, and you may be tempted to watch it. And sometimes you may have asked yourself, how did this software know that I would like this movie? The software does not know, per se, like a human being knows. The software uses an algorithm, and that algorithm has what they call recommendation system. That recommendation system is what helps the app to use multiple data and be able to generate. Let me break it down further. Let me break it down further. You 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 selected a movie. Let's say you selected a movie, or just a second, let me stop this. Let me open a Word document so that let's let's make it as simple as it can be so that you would appreciate what is happening. So I'm going to share my screen. I'm trying to make this thing very easy, for you to grasp it. Now, look at it this way. I'm going to use some names I see here. Uh, Pardon me. One. Okay. And so I'm picking names at random. So please, if I pick your name, I'm picking names at random. Mm, I'm picking names at random. Okay, so this would do. So let's say these are all the people that are watching Netflix. So look at this now. Dauda watched movie 1, movie 3, movie 4. Hmm? Clara watched movie 7, movie 1, and movie 6. Joseph watched movie 3, movie 1, movie 6. AGK watched movie 9, movie 1, movie 6. Stanley watched movie 1, movie 3, movie 6. Anusi watched, I hope I pronounce it well, movie 8, movie 2, movie 1. Yeah, stay with me. Oh. Nkechi watched movie 1, movie 2, movie 1, movie 3, movie 4. Now, these are 7 persons that have been watching movies in Netflix randomly. So let's look at those that watched similar movie. Dauda watched 1, 3, and 4. 7, this is different. 3, 1, and 9, 1, and 6. Yeah. Okay, this is movie 1. Oh, sorry, this one I meant 4, not 6. Movie 1, Stanley watched similar movie. Then Nkechi watched similar movie. Now, these are the algorithms because for every movie you watch on Netflix, it collects data of the sort of movies that are being watched. But a lot of us are not aware of this. So there is an algorithm inside Netflix that monitors the type of movie people are watching. So you see now, Dauda came and watched 1, movie 3. Then Dauda now watched 4. Stanley came and watched movie 1, watched the same movie 3, and watched the same movie 4 in that order. Probably they are talking to each other. Nkechi too maybe is talking to Stanley. Maybe Stanley is talking to Dauda. Say, you need to watch movie 1. Oh, you need to watch movie 2. You need to watch movie 4. And they've been talking to their friends. This movie is good. This movie is good. Guess what? The algorithm has picked that out of the 7 people, or out of the 7, look at this. Oh, the population is equal to what? 7 persons. Now, similarity is equal to 3. So the percentage of similarity will be equal to what? 3 times 100 divided by 7. That's equal to what? 3, I'm using my calculator. 3 times 100 divided by 7, that gives us 42.85. That is percentage of similarity for 1, 5, and 7. Now, what of 2? So 2 will be how many percent? 2 is just 1. So 2 will be 1 times 100 divided by 7. That's almost, that's very low. 1 times 100 divided by 7. That's 14.28%. Number 3 is not similar. So, in other words, 2, 3, 4, and 6 shares 14.28% each. And 6. So it's only 1, 5, and 7 that share similarity. And that similarity is higher than what 2 has, 3 has, 4 has, and 6 have. So These algorithms now is put into the machine learning algorithms called recommendation system. All right. So what is happening now? So you will now come, the eighth person will now come to watch the Netflix. Let me check. 42.8, 42. Okay, it's almost the same thing. Okay. Thank you. Yeah. So let's say now we have the eighth person. So that eighth person would be, I'm picking names at random, so please do not feel bad. That eighth person would be Iwonsu Mary. Okay. So let's say Iwonsu Mary now want to watch a movie. And Iwonsu Mary, because of the hype, she has watched movie one, she has watched movie three. The moment she watched movie one and movie three, you will see that the machine. Oh, sorry if this is too small. Sorry if it's too. So you will not. I'm sorry if it's not too. So you will notice that the moment she watches movie one and movie three, the the machine learning recommendation system algorithm in Netflix will pop up movie 4. Why? Because the algorithm, the machine learning algorithm, based on the data, has seen that over 40% of anyone that watch movie 1 and watch movie 3 will most likely watch movie 4. So once you have watched movie 1 and you probably watch movie 3, it will now recommend movie 4 for you. And you will say, how did it know that I would like this movie 4? No, it didn't know. It is using data of what people are watching to make recommendations. So this is part of what is called machine learning. You are teaching the machine how to learn things. You're teaching the algorithm that based on the data you have, you can make this sort of recommendation. This sort of thing is not only seen in Netflix. You can also see it in Amazon. You can also see it in Jumia. You buy a particular type of watch in Jumia and is recommending an item that will fit perfectly with that watch. And you're like, how did he know that I will need this? He didn't know. What it is using is the recommendation system algorithm, because the data is probably showing that over 70% of those that bought item 1 will most likely buy item 6. So the moment somebody else comes to buy item 1, the recommendation system activates and starts showing you item 6. And because the percentages and the proportion is very high, you will see that you will most likely also like it. Yeah, 14 to 8. I hope I checked it well. I did, for 2, 3, 4, and 6 is only one pattern. So I did 1 times 100 divide by 7. So 2, 3, 4, and 6, there's no pattern. They all watch different movies. So it's only 1, 5, and 7 that watch the same movie. So yeah, exactly. 1 times 100 divided by 7. Yes, will give you 14.28. Yeah, thank you for that. Exactly. Yes, exactly, Emeka, Michael. Exactly. It is the same recommendation system algorithm that is used for YouTube. Thank you. That is used for YouTube and Instagram. You watch something on YouTube, it recommends something similar. Why? Because most people that watch A will most likely watch F. Exactly. Yes, it is the same thing. Yes, it happens in Facebook as well. Watching related videos. Thank you. Yes. Facebook. Now you are getting it. Exactly. So is that recommendation algorithm that helps achieve this? So those those algorithms are at the back end. You don't actually see them. All right. It's actually coded at the back end by the data scientists, when they are actually writing these algorithms. Okay. So I'm happy you kind of understand what is happening. So let us progress now. So you would appreciate what is happening now much better. So so defining this again, the machine learning teaching computers to learn patterns from data so that they can predict or classify things. That is what machine learning is all about. So you're teaching the machine to learn. And in teaching the machine to learn, you are writing algorithms so that the machine can actually learn things. Okay, so I think that's the simplest way I can actually explain this. So, coming back to our own field, which is the coming back to our own field, which is the public health and epidemiology. What does this machine learning algorithm helps us do? It can help us predict a disease outbreak. How? How will machine learning help us predict a disease outbreak? Now, in predicting a disease outbreak, hmm, let's leave the disease outbreak and use something similar. I'll open that my Word document again. I just want you to appreciate what is happening. So let me create a new page. A lot of us are very familiar with these weather reports. I'm looking at my weather report now. Today is today is 17. Today is 17 August 2026. That is today. Now, let me do a table. I think this will make it easy for us to understand. Let me do a quick table. I hope I'm not wasting your time, because I'm just trying to make it as simple as it can be, because I know that most of us, this is our first introduction to all these machine learning, data science things. So I'm trying to, make it a bit. So let's say this is serial number, this is date, and this is whether it rained. So this is the kind of data that is being kept in the weather station. Something like this, as simple as it can be. Incidence rate and prevalence. Okay, we will talk about incidence rate and prevalence maybe later. Yeah. So I want to use the weather now so that you will appreciate what is happening. Let's say 1, 2, 3, 4, 5. Let me make it. Let me add more. This is 6, 7, 8. Sorry, 7, 8. Let's say 9. So let me start from today and I'll go up. Hmm? Today is 17th August 2026. I also have this 2025. I also have this 2024. I also have this 2023. I also have this 2022. I also have this 2021. I also have this 2020. I also have this 2019. And I also have this day 2018. So weather report is being collected for years. So let's say for 9 years now. So let me change this to years. So this is year 1, year 2, year 3, year 4. So this is the 9th year. Okay. So In 2018, it rained on this day. 2019 on this day, probably no rain. Sorry. It rained, no rain. So let's say 2020, there was no rain on this day. 2021, there was rain. 2022, there was rain. 2023, there was rain. 2024, there was no rain. 2025, there was rain. And 2026, today, there was also rain. So now let's look at the percentage. Percentage of rain in 9 years will be what? One, this rained, rained, rained. So we have 1, 2, 3, 4, 5, 6. Good. So that's 6 times 100 divided by 9. That is equal to what? 6 times 100 divided by 9. That gives us 66.7%. So based on the data that is collected for 9 years, now we have the 10th year, 17th August 2027. What do you think, based on this data, the weather report will say? Is it rain? With the weather report 66 exactly. So based on this data, what will the weather report say? 17th August 2027. It will exactly. So most of us will look at the weather report telling you, it will rain today, and it now rained, and you're like, how did he know? This thing is so accurate. Oh, it is accurate because of the data. Once the data over 10 years, 20 years is showing that on this 17th August 2026, the probability that it will rain is high, over 60%. Exactly. So it will, based on that probability, say it will rain. Of course, we may get to 17th August 2027 and it will not rain. There's no problem. But the probability of rain falling is high. But if, someone was asking if it was 50%. Thank you. So if it was 50%, you will see that it will not show rain. It will say cloudy weather. It will say cloudy weather, but it will not show rain. Thank you very much. So 50% it will say cloudy weather. Thank you. Because the chance of it happening is 1/2. Thank you, Obed. And I mean, all of you are contributing on the platform. So this is really making sense now, B. Thank you. Okay, so now let's go back to 50% likely to rain. Thank you. So it will just say cloudy weather because it's not sure. Because it's in the boundary, it will not say dry. It will not say wet. It will just say cloudy because of the data. So the people that work in these weather stations, it is data they have collected over the years they are using to predict. Like this morning, my laptop is already telling me that it's going to rain. How did he know that it will rain? Because the probability of raining over the past 20 years is high on this day. Sports predicts use similar machine. Exactly. Sports predictors, thank you. They use similar machine learning algorithms. Exactly. Now you're getting the gist there. Okay, so let us now move on to the PowerPoint slide again. Um, yeah, so I'm going to open the slide again now. So we can now progress. If anything is not clear again, I will still come back. So looking at this now, based on this, so betting is also machine learning. Yes. Betting is also machine learning. Yes. They also use that algorithm to predict. Yeah. So to look at it this way, two clubs have played so time. They have played, so every time they play, the result is captured. So if they now play in 2025, what is the probability that if these two people jam, this will win this person? Is based on data they have collected over the years that you don't have access to. You don't have access to that data, but their algorithm have access to that data. So based on that algorithm, they are able to see that, no, if these two people play, A will win B. But you that don't know now, you will now be saying, oh, B will win A. You now bet your money and they eat your money. So it uses the same. Ah, somebody say betting a pure data analysis. You don't know before. You don't understand how machine learning they use. They do now. Oh man, now you know. Okay, so that's why you need to tap into the machine learning fever, because that is where the world is going to now. So if you have an opportunity to tap in, please tap in. Okay. The International Center for Theoretical Physics I told you about, the summer school will be holding again in November in Italy. So those that are interested, the applications are not open, so I may not be able to share the link. If you're able to remind me, maybe if you remember and you're able to remind me, around that October, I think application should be open a month before. Maybe around that October, I can share the link, you apply. I can also provide a recommendation letter for you. I know that a few persons I provided recommendation letter for got the opportunity to go and learn data science in Italy. All right. So I know that I would be able to post that opportunity in the JP Analytics Learning Hub. I know most of you are already there, so you will see it when it opens. I will post it there and provide recommendation for those that need one. All right. So yeah. So what I can share, application is not open. There's still times. So what I can share is the JP Analytics WhatsApp. It's a learning hub, so you can stay there, so that when it opens, I will just drop it there. Um, yeah, I will just drop it there. And another thing, I don't know. Okay, so I don't know. Yeah, so this is it. And I don't know if like for those of us that are inching on learning, um you can also find Solence in the YouTube page. You can also find Solence in this YouTube page. I think I should have like 27 videos there now. You can visit and learn, or you can have a lot of webinars and workshop I have done. Okay. All right. So let us now move on to the class. Our time is running, but I needed to do this. I needed to do this so that you would really appreciate what is happening. Okay. So see, in public health and epidemiology, machine learning helps predict disease outbreak. So what does it mean when it say predict disease outbreak? It simply means that every two years there's a disease outbreak in community A. There's a disease outbreak in 1999 there. There's a disease outbreak 1999, 2020. There's a disease outbreak 2021. There's a disease outbreak 2023. There's a disease outbreak 2025. So by default, you can tell that the probability of a disease outbreak in 2027 is paramount, because over the years there has been disease outbreak in that community every three years. So when they say machine learning helps predict disease outbreak, this is what they mean. Machine learning studies pattern, studies algorithm. All right. It's like somebody that says you want to marry let's say a lady, you want to marry a guy. Every little thing that happens, the guy slaps you. Every little thing that happens, the guy slaps you. You've been dating this guy for almost 1 year, 2 years. And in that 2 years, you have received beating almost every two months, three months. And after 2 years, the third year, the guy is proposing to you. He wants to marry you. And you are very excited. You now marry him and say, okay, when I become a wife now, he will now be more responsible. He won't touch me anymore. You now marry him. On the honeymoon, he gives you the first slap. Boa. You say, I didn't know. I didn't know that this guy is like this. Are you sure? Are you sure? Because if I study the algorithms, the machine in him has been learning. It has been learning. Exactly. The lady needs a machine learning algorithm. Because the machine learning algorithm shows that the probability of occurrence is high. But yet, you ignore the probability of occurrence. Because you think that when you change the environment, the probability of occurrence will reduce. Exactly. The red flags were very high. Exactly. So this thing works everywhere. Machine learning works everywhere. Okay? You are able to study algorithms, even in life. That way, you'll be able to avoid a lot of headache. It's the same thing. Have you noticed that once you are interested in something, you see it everywhere? That's a mind algorithm. The day you are interested, listen, like, let me give you an example of mine. I love wearing trainers, apart from the fact that I use it to exercise, to jog and all that. But I love wearing comfortable shoes. Okay. And there's this comfortable shoes that I love so much. It's called New Balance. I know I love Reebok, I love Nike, but I have this strong love for New Balance. And the moment I have actually bought it once, and after using it, I fell in love with. I said, this trainer is fantastic. All right, so I started looking for it. I said I need to get it again, and it's not very, and it will interest you to know that, because I was interested in New Balance. When I look at people's leg, I will be seeing New Balance. I was coming out from work one time and I saw a lady, and she was wearing New Balance. I said, madam, how now? I greeted her as if we knew each other. I said, I love what you're wearing. New Balance. She said yes, that she usually wear the market seat or all that. I got her contact, but interestingly, I didn't follow up, because few months later, I traveled to Rwanda, and my host took me to a shop where they sell shoes, and I was able to buy a New Balance there. So what I'm saying is, once you're interested in something, the algorithm in your body starts showing it everywhere. The moment a guy decides that, oh, he wants to buy a particular type of car, trust me, it will seem as if that's the only car that they are manufacturing now. Everywhere he looks, you'll be seeing that particular car. And that was not like that before. So this algorithm works everywhere. Exactly. Yeah. Godspeed. Yeah. Puts it where I said the day you pick interest in something, all of a sudden you start seeing it everywhere. Exactly. That's the machine learning algorithm inside of you. You know? So your body is now learning how to identify your love, you know. Yes, we have it on Facebook. So when it comes to predicting disease outbreak, that's a very good example. You notice in a community during a particular time there's a particular outbreak. Even in the United States there's a particular time they say flu season. So what do? Because they know at that particular time there would be an outbreak of flu. They have everything that they need in place. There are a lot of communities where they know that at a particular time there will be flood. At a particular time there will be flood. They prepare for it. But sometimes here is we would wait for the flood to happen, then we will now start preparing for it when it has happened. Your data would have shown you that at a particular time every year there will most likely be flood. So what do? Because of that prediction, you prepare. And preparation means improving health services, improving surveillance, using the opportunity to identify high risk, those that are in the environment that will flood more. And as a result of that flooding, that may also cause disease outbreak as well. Dr. Stephen, well, I don't know about that too. He said even when you pick interest in a lady, other men will pick interest too. Well, I may not look at it like other men are picking interest. Those men have been there. But it's just that since you're not interested in the lady, send. But the moment you begin send the lady now, everybody that comes close is a threat. That's what is happening. You want to protect your own, but be careful, oh. Don't be an umbrella and cover the lady from the ones that are serious. You can be admiring from afar. Then when you're really truly ready, you can come close, so that you don't uh reduce the probability of our chances of being significantly identified. Eh? Uh-huh. So so that is what is happening. Okay, so let's go to the next slide. So there's something in machine learning they call supervised learning and unsupervised learning. You will see it in machine learning. To make it easy so that you understand, supervised learning is the machine is learning from a data that you yourself that is training the machine. You know what you want from that data. For example, you collect a national data on COVID-19. That national data you collect on COVID-19, you know the variables that are there, whether they have COVID-19 or not, yes or no. What are the risk factors they are mitigating? Are they covering their nose? Are they washing their hands? Are they avoiding crowded place? All those things, they are in that data. You know the variables in that data. So you now want to use that data that are labeled and put inside your algorithm and instruct your algorithm to be able to identify the people that are more susceptible to having COVID-19 based on the labels you have. In other words, you have been able to write an algorithm to tell the machine that there are certain risk factors that will make these participants or these respondents more susceptible to COVID 19. If they are not wearing nose masks, if they always attend events in a crowded place, if they don't have a habit of washing their hands, if they have comorbidity, they are elderly, you have been able to tell the algorithm that these things are the risk factors. And you now want your algorithm to use these risk factors to predict the people that are more at risk to COVID 19 or not. The machine learning algorithm is going to do that for you. So that is supervised learning. Supervised learning in the sense that you that is writing the algorithm, you know what you want. So the machine is learning, but you are supervising the learning, meaning that you know exactly what you want from that data. That's why it's called supervised learning, because you're teaching the machine to learn. So when you say supervised learning, that is what it means. You're teaching the machine to learn, but you that is teaching the machine, you know what you are looking for. So imagine your algorithms predict that somebody that is younger is more at risk of having COVID 19 than somebody that is elderly. Because you know what you want, you will go back to that algorithm and look at it. So, no, something is wrong. Maybe there is a code that I missed. Now, these algorithms and these code things and all that, you may get an idea. I did some of them in our last class, but I have a full webinar on Arrow. So for those that want to learn how to use programming to analyze data, maybe you may go through my 2 hour full Arrow class. I have all the video how to install Arrow Studio and all that. So maybe when I'm talking about code, algorithm, and all that, some of you are wondering what I'm talking about. All right. So maybe this course will truly help you appreciate um, what I'm talking about. Okay. So let me paste it in the chat box. So the class I did the last time was data wrangling and visualization. I did a little bit of Arrow demonstration, but that was just for the class. But to learn the Arrow from the scratch, all the lecture notes are there on the YouTube description. It's very, very loaded, okay? So I will encourage you to go there and soak yourself and learn these things, okay? So Arrow programming full course, 2 hours, okay? So yeah, so let's progress so that when I'm talking about algorithm, I know some of you are wondering what I'm talking about. It's your ability to actually write code to give you something you want. So in that Arrow, once you go through that lesson, you will see that I will write a code, and the code I've written will be able to generate what I want. So in supervised learning, you're writing a code, and you that is writing the code, you know what you want. You know what you want the machine learning to learn and give to you. So if you're not getting it, you rewrite the code, you structure it, and all that. That's what supervised learning is all about, because the datas are labeled, you know what you want. But there's another one they call unsupervised learning. That one, the data is not labeled. You don't know what you want. You put all the data inside. You allow the machine to identify patterns in that data and give you what you want. One example I will give you is something they call sentimental analysis. I don't know if you have heard of that term, sentimental analysis, before. Let me wait in the chat. Has anyone heard about the term sentimental analysis before? Sentimental analysis before now. It's a part of machine learning. Sentimental analysis. Has anyone? Okay. So no, okay. No one. Okay. All right. It's completely fine. Oh, Efiri, you say you've heard of it. Okay. So please, I would open the mute. I would allow to mute. Please, can you raise your hand if you want to speak so that I want to hear what you know of sentimental analysis. Yes. Sorry, just a second. Let me go to the beginning so that I can. Yeah, so let's start with Efiri. Efiri, please go ahead.
Good evening, sir, and good evening, class.
Yes.
So, okay, I've heard about sentimental analysis from my friends, AI guys, and what they explained to me is like a way to classify text, to understand intent if you are doing natural language processing. I don't understand the core technicalities of
Okay.
how it works.
It
But I
works. Okay.
understand that you cannot use the data and then understand intent in natural language processing. So that's
Thank
what I've
you.
heard about.
All right. Thank you. I like that term. That word you use. Intent. Intent. I like that. Thank you very much. Maputo. Maputo, please go ahead. Tell us what you know.
Okay, good evening, class.
Good
Okay, so
evening.
in that, it's a sort of technique that uses the NLP, the natural language
Language
processing,
processing,
and
correct.
machine, yes, NLP and machine learning to identify and classify emotional tones. Like
Emotional
it's
tones.
basically, yeah,
Correct.
yes,
Correct.
and then
Okay.
it is expressed in text data. That's
Thank
the
you.
whole idea I have
Correct.
about it. I'm not
Correct.
actually
Correct.
delved deep, but that's
Okay.
it's
Correct.
how you have to learn how to give those emotional tones and express them in text data. Maybe
Oh,
something like
beautiful.
positive, negative, or
Negative.
your neutral.
Yeah.
Yes, yes.
Okay,
That's the idea I
beautiful.
have about it.
Yeah, beautiful. Thank you so much. That is it. Emotional, intent. I love all those words. Godspeed. Godspeed, Onoha.
All right. Let me try to define it. Let me say in a layman's approach. So, if we say sentimental analysis, it's just a way. Let me use. We're trying to judge reviews or people's comments about a particular subject. Let me
People's
say, as we're
comments.
learning
I
now,
love that.
we want people to say, is this class going on well or not, and something like that. So, in sentimental analysis, you use it to try to judge or determine people's opinion, whether they are positive or negative, or whether they are neutral. So you apply sentimental analysis to how people react to things, and machines use this sentimental analysis to make reviews about, let me say, opinions and options and a whole lot of things.
Okay. All right. Thank you very much. Everything the three of you said is correct. Okay. So I would explain it. It's the same thing you have said. So now let me put a practical this touch to it. Many years ago, I attended a workshop on data science. But this one was in Nigeria. I did it in I think in Akure. I was selected, but I had to pay my way. So I have made a lot of sacrifices. So for the knowledge that I have today, I've made a lot of sacrifices. I've gone for meetings that, even international meetings that I funded myself, just because I want that knowledge. Because at the end of the day, see, let's be real. If you like, be working with Dangote or be working with SPDC or working with anywhere you're working. The day they tell you, thank you very much, we don't need you anymore, the only thing that goes with you is your knowledge. You can't take the gas pipeline with you. I hope you know. You can't carry one chair there. You can't even take 1 cup of crude oil. The only thing you can carry is the knowledge and the certifications you have gathered while you're there. So if you're in a place and you're working, oh, I'm working hard, what is the evidence that you're working hard? The evidence that you're working hard is the certifications to show. A lot of us, we have amazing skills. But guess what? Nobody will employ you, even if you have those skills. They are seeing those skills, but they will not employ you. You know why? Because you don't have certifications to back that skill. Very critical in our time now. So, if you have been able to develop some skills on your own, please go to platforms and find where you can get certification. The certification is not because you don't know it. The certification is so that you have an evidence to show somebody that you know these things. For example, you are applying for a job as a driver in an organization. What will they look at first? Is it your driving skill or your driving license? They will first of all ask you for your driver's license, your driver's certifications, before they will even give you car to drive. You will not go to a place they say, okay, don't worry, leave your license, leave your certificate. Let's see if you can drive. So if they see that you can drive and you don't have a driver's license, they will still tell you, thank you very much. We are looking for somebody that have driving. Even if the person that has driver's license does not have your experience in driving, what makes the difference is the certification for that skill you have built over the years. So part of what you should be doing 2026 going forward is asking yourself, what skills have I built naturally that I need to certify? I know in Nigeria and in many African countries, we take these things for granted. Yeah, sentiment and analysis. Yeah. So they call it sentiment analysis. Sometimes they can call it sentimental analysis. It's still okay. When you say some certificates are not globally recognized, I'm not talking about academic certifications. I'm not talking about bachelor, master's. No, I'm talking about certifications that prove that you have this skill. That is what you should be targeting. So if, for example, now you're a good chef, you know how to cook. Prof, thank you very much, Dixon. Exactly. That's a better way to put it. Professional certifications. Yes, thank you. Professional certifications. Professional certifications, they come from a body. So it's not about whether, yeah. So I know in Nigeria and many other African countries, we take these things for granted. Do you know that in the US, you cannot do carpentry work if you're not certified as a carpenter? In Nigeria, yeah, people will come and do carpenter work. You won't ask them for certifications. But they are very good, though. They will do the work well. And they will go. You will pay them. Electricians will come, do the one they can do, spoil the one they can spoil. And you say, this man don't know what he need to do. He will go. Some of you have used more than 5 electricians in your house. They have still not gotten the problem. But imagine in a system like in the US, where for you to be an electrician, you will be certified. And your name will be in the register. So if I need an electrician to come and fix my light in the US, I will go to that body, check for those that are certified, check their certification number, and I'll call them. And when they come, they will get the job done. You know why? Because if they don't get the job done, they have a body where you're going to report them. Cisco, NEBOSH, exactly, all those sort of things. So a lot of us are very skilled. We are very professionals in the things we do, but we don't have certifications to back that skill. So please let this be part of your goal for 2026. Begin to acquire certificates that recognizes your skill. All right? Professional certificates that recognizes your skill. I mentioned some of them in my first class, Coursera, EDX, FutureLearn, Allison. I think Allison, most of their courses are free. If you have money, you can go to Data Camp, and the rest of them and get certifications to back up the skill that you have. Very, very important. Yeah, reputation is at stake, exactly. So now, why did I bring up this sentiment analysis stuff? So like I said, I went to Akure then to learn this stuff. And my group, our project was sentiment analysis. All right. So we extracted data from Twitter. Then it was called Twitter. Now it's called X. We extracted data from Twitter on people's sentiments regarding network users like Glo, MTN, and Airtel. And we analyzed the data to be able to show people's sentiment on these three networks. But the organizers had to kill the project. We were not allowed to present it for, so that, for litigation matters. Imagine coming to say this network is better than this network and blah, blah, blah. They may sue you, because it may be like bad market, you see. So we couldn't take that beyond that class. But that is an example. So Allison is free. You only pay after finishing the exam. Okay. You can apply for scholarship on the e-learning platforms. Okay. So these are places. So instead of spending hours watching reels, I don't have any issues with reels. So before those of you feel that every time is always talking about reels, I don't have any issues with reels. But trust me, the hours a lot of people spend watching reels and laughing and gisting and chatting, you would have acquired today. Today I got another certificate. I've added it now. So it's going almost like 30, should be 30 something now. Few weeks, 2 weeks ago, I got another certification from the University of Washington. I did a course in global health there with my colleagues in Akagan University in Kenya. So they sent me the certificate. I've added it. I'm always working, always reading, always certifying. I have this skill. Where's the certificate to show for it? I go and get it. Very, very important. Okay. So when it comes to the unsupervised, that is an example. Unsupervised simply means you don't know what to expect. All you need to do, you just gather the data. The data does not have labels. It doesn't have labels like in the terms of COVID-19, you may have labels like washing your hands, yes or no, nose covering, yes or no, present in a crowded environment, yes or no. All those kind of labels it doesn't have. These are data. Agora, I don't know what that means, Abel. These are data that you are extracting from Twitter, from Facebook, from YouTube. They don't have labels. They are just scattered everywhere. They are often called unstructured data. You gather them, put them in the algorithm, and you study what the algorithm will come out. So it is the machine learning that will come out with a pattern based on how much it has learned. So that's why it's called unsupervised. Unsupervised because you don't know what to expect. You don't know what to expect until the outcome comes out. So during COVID-19 break, you can gather data from different states, put them together, and you don't know what you're going to find because the data is not structured. And the algorithm will be able to come up with patterns based on that data. Okay, Agora, yes. Oh, yes. I remember Agora. I think it's the agricultural one, right? Agora Agriculture. I think I've done a course with them. I think it's the agriculture. I think so. I may be wrong. Agora, yes, it clicks a bell now. Okay, yeah, thank you. So please, UNICEF. UNICEF is there. So please, go and learn. Oh, go and learn. 2026 will soon finish. I want you to be able to send me a WhatsApp message in December and say, oh, we are in August now. Please challenge me. I want you, December, you are sending me a WhatsApp. Felix, I have 3 certifications. Oh, I have 4. I have 5. Oh, I have 10. Oh, challenge me before the end of the year. Reduce your reels and YouTube. Put your ears and study. All right. These certification courses, yeah, there are just find. Okay. If you're not able to find, you can do me a WhatsApp message later. If I see, I know that I see these things occasionally, but the ones that are in my head is the ones that I'm sharing with you now: the Coursera, the EDX, the Future Learn, Agora, like they have said, and other platforms here, Allison, that had been mentioned. Please go in and learn and keep yourself busy, okay? So that when you are eating your Christmas chicken, you'll be happy eating the chicken and telling yourself, I have 10 certificates, ha ha ha. I'm enjoying my chicken, It makes a whole lot of sense. Okay. All right. So that is it. Okay. All right then. So let's see so that we can wrap up. So, like I said, supervised learning in public health. Yeah. So it's easy to use supervised learning in public health because most of the data we collect, they are labeled data. All right. They are labeled data. So you may collect the data, and that data will help you predict diabetes, predict heart disease, predict TB. Of course, if you want to collect the data that will help you predict TB, what are the things that you will collect? Of course, those that live in crowded environments. Have you been coughing for more than so weeks? Do you have a family member that has been diagnosed with TB? These are structured data. So by the time you're able to gather all these informations, you can now guide the algorithm. You can now guide the algorithm to now predict what you want it to predict because you know what you are looking for, because you have an idea the type of data you have collected. All right. So that is how it works. So I had some examples here. Predicting hospital readmissions is possible. So in a hospital, you have the medical record, and this will work better in hospitals that use electronic health records. So from the electronic health records for 1 year, you'll be able to tell the patients that will come back to the hospital based on their history that they gave during the clocking and the rest. When you put that data in the algorithm will be able to predict the ones that will come back for readmission based on their lifestyle, and also you can use that data to also predict the conditions that are costing the hospital more and the conditions that are costing the hospital less. Then the hospital will be able to tell or know how to reduce cost. I'm sorry, I think I opened the mic earlier on, so let me close it back again so that our room will be quiet. So we are still talking about supervised learning. So I mean, you get the concept of supervised learning. The data you are collecting now in your masters, you can use it for supervised learning because the data, you are familiar with the data you are collecting. So you are able to use that data to predict what you already have in mind. So you're teaching, because the algorithms you are writing, you have an idea. So you're teaching the machine to do the work for you. You are not the one running the prediction. Is the machine that is doing that. And an example of a machine is Arrow. So when I'm saying machine now, you're feeling, oh, is no. The Arrow statistical software is an example. of a machine you can use to do some of these things. So the unsupervised, like I said, is basically you picking data from an environment. You don't know what to expect. All right. You can go to an environment, they are smoking people, some people are not smoking. You collect all the data. The data are not labeled. Anything, you just, extract them. You can extract the data from Twitter, you can extract the data from YouTube, you can extract the data from, it doesn't have to be a labeled data. Like I told you, we extracted from Twitter. The machine, based on years of learning, will be able to study a pattern that is happening in that data. More like when you go into a class to teach. If you're a very sensitive lecturer, you'll be able to study the pattern and know how to help the students. Okay? So I think that is basically it. Now for decision tree, this is also very, very easy. You probably have heard of decision tree before, but this is what decision tree is like. Fine, it is a tree that helps you make a decision of what is going to happen. Now, let's practicalize it. Let's practicalize decision tree now. Oh, somebody says my voice is breaking. I'm sorry, is it still breaking? Oh, there. Is my voice still, is it still breaking? No. Okay. All right. Sorry about that. Okay. All right. Okay. So let's practicalize decision tree now. Let's practicalize decision tree. Now, let's say you are coming from, watch this. Oh, you're coming from Nigeria. You have an ECOWAS passport, and that ECOWAS passport does not have any visa on it. You now take that ECOWAS passport and now go to the international airport, and you go to the counter that is going to Indonesia. You go to the counter that attends to people. Decision tree helps you do what? Yeah, so I'm trying to explain the decision tree now in a term that you would understand. You are from Nigeria, you have an ECOWAS passport. You take that ECOWAS passport to the international airport. You take it to the counter where they are taking passengers that are going to Indonesia. And you give them your passport with your luggage and say you want to go to Indonesia. Can you tell me what is going to happen to the person? What are they going to tell you? Yes or no? Thank you. Thank you. They are going to tell you no. Why? Because you don't have a visa on that passport. Good. So let's look at another scenario. You have the ECOWAS passport. You take the ECOWAS passport to an international airport. You go to the counter in the international airport that is going to Ghana, and you have your luggage and you want to travel to Ghana, and you give them your ECOWAS passport. What are they going to tell you? Yes or no? Thank you. Now you get the gist of decision tree. Now you get the gist of decision tree. Decision tree is like a process map. Thank you, Erasmus. Somebody is saying Akwaba. Emenike, are you staying in Ghana? This one you're saying Akwaba. Leave my Ghana people to say Akwaba, unless you're living there. Leave it for the Ghana people. Let them be saying the Akwaba. I was in Ghana, I think I was in Ghana. Okay, I'm seeing. I think there are definitely Ghanaians here. I think I was in Ghana during the COVID-19 time. Yes, I went to Accra, but Accra was not my primary destination. I was actually going to Cape Coast, University of Cape Coast. So I got to Accra. So they took us in a bus to the University of Cape Coast. So yeah. So, Akwaba. So you leave Akwaba for the Ghanaians. Okay, please don't mind me. All right. So now you get the whole gist of the decision tree. I like the way Erasmus said it. It's like a process map. What is happening in A, B, C will determine what will happen in D. That's how it works. So let's look at an example of a decision tree. I have some very good examples here. Okay. Oh, there. I'm sorry about that. Yeah. So I have very good examples here. Oh, there. This is what is happening. My slide is dancing. Okay. So I have very good examples here. I'm sorry about that. Okay. So I have very good examples here. So look at this malaria risk decision tree. And people that work in people that it is decision tree they use for contact tracing. During COVID-19, they were doing a lot of contact tracing. What did you think they were using for contact tracing? It's decision tree. Okay. Motala Hassan says a decision tree in public health is a step-by-step decision-making tool that helps health professionals determine what action to take based on a sequence of questions, conditions, or test results. It is usually presented as a flowchart where each answer leads to another question or to a recommendation action. Exactly. Thank you for that, Hassan. So that is what it is. During contact tracing, is decision tree that was used. Where did you go to? You say you went here. They go, like that until at the end of the day, they are able to identify who is most likely at risk. Okay. So look at the malaria risk decision tree. Somebody that lives near stagnant water. Somebody you live near stagnant water that inhabits mosquitoes. And you don't sleep under mosquito nets. You'll be at a high risk. You see it there. Live near stagnant water. Yes. Sleep under insecticide treated net. No. You'll be at high risk. However, if you live near stagnant water, but you sleep under insecticide treated nets, you will be at a medium risk. If you don't live near stagnant water, you may be at no risk. That's how decision tree works. Decision tree is like a doctor using the signs and symptoms to recommend different tests to be conducted by a patient. Exactly. Thank you, Obaro, for that. Thank you, Abel, for sharing the link for Allison. Please go and learn. I want all of you to, by December, you should give back report. I want to hear report by December, how many certifications you have gotten. All right. So predicting COVID-19 testing, somebody has high fever or cough. Yes. They have traveled recently. Yes. So the priority is high. I remember one of the times I think my second trip to Ghana, I was actually on my way to Lagos to take a flight to Ghana. And where I did my COVID-19 test, they called me that my COVID-19 test, it tested positive that I should come back. So I had to return back to Port Harcourt to quarantine for I think 3 weeks or so with my family. So I missed that Ghana workshop. I had to call the coordinator and they were really not happy because my ticket was already paid for. You know, someone was saying the mosquitoes nowadays don't even need stagnant water. They are everywhere. Okay, now, but we are trying to be scientific. Ogechi Wigwe, we are trying to be scientific, and scientifically, we know based on textbooks that mosquitoes live in stagnant water. So let's stay there. Your your postulation your postulation needs to be scientifically verified before we can use it, Ogechi. So maybe you can add that as part of your project work. Why are mosquitoes leaving stagnant water? you know, why are mosquitoes not staying in stagnant water anymore? You know, so uh, yeah. So somebody says something like this. Yeah. So this is beautiful. Global Health Learning Center. Yes, this is beautiful. This is beautiful. Beatrice Okon, thank you for sharing that. Yeah, thank you for sharing that. Okay, so predicting COVID-19 has fever or cough. Yes. Traveled recently. Yes. High priority. Yeah. But has fever or cough? No. Low priority. But if you have fever or cough, but you have not traveled recently, your priority may be medium. So predicting TB infection, the same thing, you know. So for TB infection, yeah, Maputo, thank you for that. The certification should be on your skills, things you know how to do well. For example, you are a laboratory technician. You know how to do phlebotomy very well. The only certificate you have is the fact that you did medical laboratory, BSc medical laboratory. Now you want to do masters in public health. What's the relationship between masters in public health and your skill in phlebotomy? So to sell yourself better, you need to go online and check certification courses on phlebotomy. They will be there. You do one or two, add it to what you have. So if there's a lab somewhere, anywhere, and they say they are looking for certified med labs, and you submit your BSc in microbiology or med lab and bring out those certifications as well, who do you think they would honor more? Is the one that has the degree and also the certifications, you know? Yeah. So somebody said you did BSc in microbiology. Now you're doing MSc in the public health, you know? So why are you doing MSc in public health? There's the reason why you're doing it. Probably there's a skill you want to build. So get certifications around those skills you want to build or you already have, just to strengthen yourself. All right. Okay, so that is it for decision tree. You get you get the gist. So this is an example of decision tree I used in my PhD. You know, where my PhD is on HIV self testing. So from the HIV self testing, yeah, so you can see that there are certain variables that are predicting more, and there are certain variables that are predicting less. Those that are less than 47 years, using HIV self-testing, the prediction is for years is low, 24%. But for those that are greater than 47 years, the prediction for using HIV self-testing is pretty the the no for those that are greater than 47 is 76%. But for those that are less than 47 years, it's 24 percent. So that's how the decision tree kind of works, like the example that I showed you. Sorry, we have to be wrapping up. I've kept you so much. So decision trees in epidemiology, like I've shown you examples, we use it to classify disease, decide who gets a vaccine, who doesn't get a vaccine, and guide to screening process. Now, the random forest is more like bringing so many decision trees together. So decision tree is a tree. So where you have so many trees, it will form a forest. So when you have so many decision trees coming together, it will now form a forest. So that's why it's called random forest. So random forest is simply combining of many decision trees into one strong model. So this is an example of what I mean. So this is more complex than what you saw before. So these random forests will help the doctor or the clinician tell how to handle COVID-19 hospitalization so that they don't get overwhelmed. So if they have a patient now that comes into the hospital, they assess the patient and the patient has oxygen saturation of less than 92%. The moment that patient has oxygen saturation for less than 92%, yes, they are going to hospitalize immediately. But if the oxygen saturation is not less than 92%, they will not hospitalize. But if that particular patient, even if the oxygen saturation is not less than 92%, but that person is over 65 years, they will still hospitalize. All right. So, in other words, different decision trees coming together is what they call the random forest. So that at the end of the day, based on the oxygen saturation, shortness of breath, having coughing for 10 days, you'll be able to tell whether these are hospitalized patients or they are outpatients, so that you don't overwhelm your healthcare system. So when it comes to support vector machines, okay, support vector machines is actually a machine learning algorithm that classify people based on their habits and based on what they are going to develop in the future. So more like you are in an environment and you collect data of those that are smoking and those that are not smoking. You can use the support vector machine to classify them into those that you know will likely develop lung cancer and those that will likely not develop lung cancer. And why are you using vector machine to make this classification? Because they have some risk factors. They smoke, they are in an area where it's smoky, and also their age. So the support vector machine is simply an algorithm that is used to classify people. Imagine you go to the antenatal clinic. You can use support vector machine to classify women that will most likely have preeclampsia and those that will not, based on their history of hypertension and also family history of preeclampsia. That's what the support vector machine will help you do. Classification, basically, based on a history of a risk factor. All right, like I mentioned to you now, this the smoking history. Vector machine, the support vector machine will be able to classify those that have a high smoking history into the group where they are likely to develop lung cancer. That's what the support vector machine does. So it's a way of predicting an outcome based on the history of that patient or that participant. Okay? So looking at this now, this light cycle is people not likely to develop lung cancer, while this thick one is people likely to develop lung cancer. All right? And how are they classifying it? Based on the increase of pollution and based on the increase of smoking. So the more they smoke, the more they are in the place of what? Pollution, they will most likely develop. So that is why you see that when you have a line like this, when you have a line that cuts across like this, it means that as this is increasing, this is also increasing. And as pollution is as smoking is increasing, pollution is also increasing. And as smoking increasing, pollution is increasing. That is why class A, they are up here, because the chances of developing lung cancer is high for class A. But for class B is low because of these people have low smoking and low pollution. So neural network is, and so this thing I'm just giving you, this is like an introductory class on machine learning. That's why I'm just touching most of the concept you will see in machine learning. All right, so this is like an introductory machine learning. Please, it's not really a deep class. So the neural network, you probably would have heard of it. For some, it's inspired by how the brain works. Okay, so it's a neural network, meaning that the algorithm has the capacity to learn from complex relationships. So imagine you have a data, and that data has CD4 counts, that data has viral load, that data has treatment history, and many other variables. If you put that CD4 counts in the neural network, you put the viral load in the neural network, you put the treatment history, you put the medication history, all right, you will see that the neural network is able to assess all this data and come up with recommendations. It will tell you, this set of people will need medication quickly. This set of people may not need ARV now. They have to be monitored so time. This set of people will not only need ARV, but they will need ARV and supplements. This sort of people will need hospitalization. That is neural network for you. The same way the human brain works. Imagine you come into imagine 10 HIV patients comes to see a doctor. And imagine the doctor, reviewing these 10 patients, and each of those patients is telling them the same thing. You go and take the ARV drug. You go and take the ARV drug. You go and take the ARV drug. You go and take the ARV. And that's the same thing he's saying for the 10 persons. You will know that something is wrong with that doctor. You know why? Because the recommendations is based on the input of the patients. Imagine a patient comes and their CD4 count is high and their viral load is low. The recommendation for that kind of person will be different from someone that their CD4 is low and their viral load is high. So neural network behaves like a human being. It uses all this data to make recommendations. And it is neural network that they use to build the machine learning algorithms that a lot of doctors use in their hospitals today. In most hospitals, they don't even bother asking a doctor. The doctors don't even bother trying to crack their brain and read textbook on what to tell you. As you're talking to them, they are typing it in the system. As you're talking to them, they are typing it in the system. As you're talking to them, they are typing it in the system. Once you finish talking, they just press enter. The neural network will read everything the doctor has written and will provide a recommendation for the patient based on those inputs. Because the neural network is a machine behaving like a human being. It has the ability to think wide and make different recommendations based on the input data. So that's how the neural network works. So deep learning, this is deep learning. So I don't want to talk too much when it comes to deep learning. I want to show you examples of deep learning. This is an example of deep learning, meaning the algorithm has learned so much. Imagine If you go to, by God's grace, I have been to China. And however, what China is doing now, it makes life easy. In China, if you see a billboard, yes, they will write the Chinese. They will write the Chinese. So let me show us. So maybe you don't feel like. Yeah, let me show you. So this is it. Yes. So let me show you. Proof. So this is the proof. Hmm? I was in Beijing for almost, I don't know, maybe 3 weeks or so. Yeah. So so that is it. Okay. So in China, they have tried to do it in such a way that if you see a Chinese language, it will be in big, it will be bold, but they will write the English in small letter. So you may not need to struggle much. But Google, there's something they call Google Translate. I remember when I was in Slovenia, a lot of times we think that European countries, they speak English. The only European country I know that speaks English very well is United Kingdom. In Italy, they speak Italiano. They don't speak English in Italy. Of course, most of them will speak English, but they don't speak English in Italy. They don't speak English in Spain. Of course, Spain is Spanish. They don't speak English in France. They speak French. They don't speak English in Slovenia. I was in Slovenia. As a when you get to Italy and Slovenia, as you are approaching them, they know that you are approaching them to come and ask them question in English. As you're coming, they will just tell you English, no, so that you just stop there. English, no. So what has helped me in most of these places is I would have to find someone like me, a Nigerian or a Ghanaian or someone that is black skin. Most likely they will speak English, but the natives oftentimes will not. So I know I want to bias your mind. So don't think because is Europe, they speak English. Germany, they speak German. Although they will try to speak I think apart from UK, another place where English is freely spoken is the United States. But there's one state in the United States that they don't speak English. That is Puerto Rico. Puerto Rico, they speak Spanish. That's why when I was going to Puerto Rico, the guy at the immigration stand was asking me if I know how to speak Spanish. I just said no. We just laughed over it. All right. In Puerto Rico, it is Spanish. All right. Eros, Corazon, what's that? So many things. I'm forgetting my Spanish now. Okay. All right. So this is deep learning, the ability for the algorithm to learn advanced things like Google Translate. You just point your phone, it translates whatever language it is to the language that you want it to be. What is happening? Let me see if I have an example of it. Okay, I don't have an example of it. Okay, a very good example. Okay, so let me ask you this. Who can tell me in our time now, there's one deep learning algorithm. Sorry, I didn't put it in my slide. Canada, they speak English, yes, but you have to appreciate that Canada is divided into two places. Canada has English part and French part. Okay, yeah, it's not all everywhere in Canada that they speak English. Canada has French speaking part and English speaking part. Okay, so can someone tell me, this is what we'll do before we wrap up the class. Can someone tell me Quebec speak French? Exactly, it's not all the places that speak English. Thank you for that. Can someone tell me an example of deep learning in our time now? I'm glad I didn't put it in the slide. Can someone tell me an example of deep learning? There's some applications we are always using now that is deep learning. We are always using it now. No, AI, yes, they are all AI, but yes, Chat GPT. Thank you. Wait. Who said that first? Who said that first? Um, Juliet said, yeah, Juliet, thank you for that. No, it's not Juliet that said it first. I'm sorry. It's not Juliet. Ibi Ibiedawo. Ibiedawo said it first. Yeah, thank you, Chat GPT. Exactly. That's deep learning. You know, that's deep learning. Then Juliet said it. Okay, Chuku said it. Yes, Gemini. Thank you. ChatGPT, Cloud, exactly. Gemini, exactly. DeepSeek, the Chinese one, yes. Voice assistant Gemini, very good. Now, Copilot, thank you. So all these Novas, all these things, they are deep learning. They are deep learning. They use deep learning, machine learning algorithm to build all these things. So deep learning is a type of artificial intelligence that uses, that's from Hassan. Deep learning is a type of artificial intelligence that uses multi-layered neural networks to learn complex patterns from large amount of data and make predictions or decisions. Exactly. That's why you can ask ChatGPT something, it will be able to give you information because it is learning from large. Notice that the keyword there is large amount of data. So when you're feeding data into ChatGPT, you are teaching it to learn. The more data you give ChatGPT, the more it learns. So all those your data you're feeding in, asking them questions, they are called training data. They are called training data. The algorithm uses the data to train. Perplexity, exactly. Yes. Siri, exactly. Siri is amazing. I think I use Siri on my phone. I can tell Siri, call my wife, and Siri will call her. you know, I can tell, sometimes I try to shut my phone and it will just be taking time. I say, Siri, turn off my phone, you know, and it will get to work. So we are in amazing times. We are in amazing times. And it will be very sad and surprising for us not to take advantage of these amazing times we are in now. No wonder ChatGPT can tell about my daughter. Yeah. So we are an amazing time. A lot of data everywhere, data everywhere. So there is this application. It's a cloud-based application. Real-time pathogen detection dashboard that helps prevent outbreaks around the world. So they feed data into it. Based on the data they feed into it, is able to predict where an outbreak will happen and where it will not happen. This one also, the eye prognosis, it works, like this one. You just put the child's face. It will snap the child's face and it will be able to tell you whether that child has autism or not based on the virtual futures. These are deep learning. There are a lot of them. A lot is happening. A lot is happening. And please, don't get left out. Fraud detection, self-driving cars. Thank you. Face recognition. Exactly. These are all deep learning. These are all deep learning. So before we wrap up, tomorrow is practical class. We are done with theory. So tomorrow, so let's do it this way so that it will be easy. Okay. I'm teaching you a very easy statistical software to use tomorrow, which is EpiInfo. All right. You don't need license. You don't need anything. You just go online and download it. So I'm going to drop here some things you would need, how to download and install it. You can even go ahead of us and learn before you come tomorrow. So I have some videos on YouTube. Please, they are all here. I've shared it. So please, the first video will teach you how to download the latest version of EpiInfo. the second video, and the third already did on EPINFO. So you can learn and prepare yourself. No, you can't do EPINFO with your phone. I'm sorry. So I have given you opportunity to speak. So if you want to say something, please, you can ask your question. Onye Salom. Onye Salom. I tried the video,
Yeah,
but it
yeah,
was Onye
yes.
Salom. He said,
Good evening.
yeah. Huh.
Yeah, I tried the YouTube. I tried downloading it to my laptop, but I don't know
No,
why.
you won't.
I
No, you won't be able to download a YouTube video now. Mm-mm.
no, I'm not
You
the
won't be
YouTube
able.
info you told us about the
Okay.
last lecture.
So did you watch the video on how to download,
Yeah, the 7 minute video. I watched it. I
and you weren't
it's,
able to get it done?
it
Wow,
wasn't downloading
that's
my
surprising.
picture. It showed
If
downloadable. Use it. I wasn't able to use it.
Okay, so the only
Yeah,
thing I don't know,
there
you can.
is there is an issue with the, that it is no longer licensed by them, but then there is a way to download it. From your video, I was
Okay.
able to download and even do the part one. So there
Okay.
is a website. I think I might drop the website in the class later. There is a more secure website that you can now download from, because if you go to the original owners that are no longer updating it, you can't download from them any longer. But then
Okay.
there,
Ah,
exactly.
Oh,
But then there's another
okay.
website that you
okay,
can use to download. Yeah.
okay. No,
Okay.
no, you can't use your phone to practice EPINFO. It's your
Please do.
laptop. You can use your phone for the lecture, then you can practice with your laptop. So share. You have my WhatsApp. Share with me the link so that I can update it on my YouTube page. Hmm? Yeah. Any other question? So
Yes, sir.
any yeah, please go ahead. Please,
Yes, sir.
Christopher.
Good evening, sir. Yes. Sir,
Yeah.
you mentioned sentimental analysis, but I was waiting for the more explanation, or you throw more light on it, please.
What I
That
was saying,
sentiment.
yeah, so what I was saying in sentiment analysis is you analyze people's sentiments about a particular matter. And how you get those sentiments, one of the best places where you can find sentiments is X or Twitter. So imagine now Nigeria is in the hype of elections. There are a lot of sentiments everywhere. So you can do sentimental analysis based on the different political parties, what people think about each political party, what people think about APC, what people think about PDP, what people think about NDC, what people think about Accord, and the rest of them. So you go to X and extract. It's called data mining or text mining. You extract these tweets and put them in the algorithm, and the algorithm will be able to do sentiment and analysis for you to be able to tell you the sentiment categories of people as it relates to these different political parties. I don't know if that is clear enough.
Yes, yes, sir.
Okay. All right. So any other, please, cost rep, help me add this number to all WhatsApp group, my accounts. Okay. All right. So any other question before we call it a day? I am challenging everybody in this class. Oh, I'm seeing 308. December 1st. December 1st. I want to get a WhatsApp message. I admire your frequent international travel. Yes. Thank you. Thank you very much. And you can travel too. You can travel too. The Bible says, I know we have people from other religion here. So I think your own religion will have the same message in a different way. Okay, so the Bible says something. It says the gifting of a man makes room for him. The gifting of a man makes room for, oftentimes I apply for a job. I apply for job. I submit job applications, not because I need the job. I'm only applying because I want to know whether they will call me for an interview. If they call me for an interview, it simply tells me that I am still employable. If they don't call me for an interview, and it has been happening several times, I'm applying for a job and they are not calling me to even say, okay, we are considering you for an interview, then I can cancel the interview. Then I have to go back and look at my CV again. It's like I am becoming old school. I need to upgrade. That's why I am attending a course, in by God's grace in October, somewhere around the world. I don't want to say now. It would be a 6-week course on advanced epidemiology and biostatistics. I want to know what is happening. That course is like 3,000 euros. So, what is really happening in advanced epidemiology and biostatistics? I know that when I come back, my life will never remain the same again in terms of how I teach epid about statistics. So your gifting is what will open doors for you. So what are you improving yourself on? If you know how to make akara, how many style? There are some ladies here. I can challenge you in this class. You only know how to make one type of stew. Only one type of stew. That's what you have been making all your life. One type of stew. You have not bothered to go to YouTube. If you go to YouTube, you will see different. I go to YouTube to learn how to prepare different types of stew. You've been eating one type of stew all your life. You will marry your husband. It's the same stew you'll be cooking for your husband. You will cook it for your children. Teach your daughter the same stew. They will cook it for their own family. Generational stew, cooking ingredient. The same thing. You want to prepare. Do you know that there are so many ways you can prepare okra soup? So many ways. But you will consistency exactly generational stew. Rich generational stew. You know, you have not bothered to go to YouTube and check the different types of stew delicacies that are there. You've not bothered. So that is what I'm talking about. So I'm challenging you. All of you here. Take your destiny in your hands and be the best version of yourself. Stop sleeping. Stop sleeping. A lot of us are sleeping. I can tell you the truth. A lot of us are sleeping. A lot of us are sleeping. So you have all these opportunities. Many years ago, there was no AI. Now there's AI. Information everywhere. And you're still sleeping, watching reels. Watching AI shots, AI videos. That's all you do every day. Continue. By December, maybe it would have increased from 32 to like 40 something certificates. You'll be there watching AI short video and reels. So wake up, improve yourself. All right. Yeah, I'm having challenges carrying out the exercise on Aru Studio. If you check the YouTube description, all the manuals are there in the description. All the manuals are there. And the way I did the manual, the teaching manual is you can even copy the code and paste. It will work. It's do as I do. And I made it so simple, and I did it in Word document so that it's something you can follow page by page. So if you who are all these people posting food here? Don't make us get hungry. Let's finish the class so that we can go and relax and eat our generational stew in peace. My little girl, she's 2 years plus. Anytime I'm bathing her, the brother comes in. Guess what she will say? 2 year plus, so she will tell the elder brother, allow me to bathe in peace. allow allow me to bathe in peace. It's so funny. More like that song. Allow me to enjoy myself. Very funny song. Sometimes you wish they would just lock you up in that kind of supermarket and throw the key away. you know. So it's so funny. All right, thank you everyone. So enjoy your day. So please come tomorrow prepared. If you can prepare ahead, it will be nice, as in watch the videos, and the demonstrations before you come to class. It will be so amazing. All right. So if you're having any issue with the links I've shared, this is my WhatsApp number. I can still send them to you on WhatsApp in case you're not able to pick them out from the Zoom link. You can
That's
send me a
this
private message and I will send it to you.
this will be our own. Where is their own school?
Hello? Hello? Is it me you're asking? Okay, all right. Thank you very much. Fine boy, are we good to go?
Also, yes, sir. Yes, sir. We are good to go.
Okay, all right then. Thank you. See you tomorrow.
Thank
Come
you, sir.
prepared.
Good night, sir.
Tomorrow is
Thank you so
physical.
much, sir.
Okay, take
Thank
care.
you.
Bye bye.
God bless you.
Bless you too.
Thank you.
Bye.
Thank you.
All right, take care. Yeah, good
Thank you
night.
so much, Doc.
Thank
Yeah.
you. See you
Thank
tomorrow.
Thank you, sir. Thank you, sir.
We love you. We love your family. We love our
We
take
enjoy
care.
generational school.
Thank you.
Thank you, Prof. We love
Thank
you.
thank you. I
Love
love
how
you
you
too.
carry your family along with your profession.
Thank you. Thank you.
Yeah.
All right, take care. So keep in touch on WhatsApp. God
All
bless.
right.
Bye.
you too much. You too much. You too much.
Thank
Leave and
you. Hey.
Yeah.